surroundings. Now, everything that Marcus is doing right now happens in that device itself. What you don't know is that that device is getting hotter by the minute, and that the battery is draining really, really fast. Now, that's a very high-end device. It's rather expensive and it's extremely powerful. The trend is that devices will go smaller and thinner over time. Basically because you can't stand like this for 90 minutes watching a football game through mixed reality. It's not going to happen. You're probably going to use a pair of goggles. If you work in construction, industries, you will have a visor on your helmet. They will not have the processing power or the battery power to do that. We need to do that somewhere else. That else should be a mobile edge cloud, we argue. I'm going to talk about why it's mobile in a few seconds as well. So, should we do the portal, or should we? All right. Yeah. Let's do it like this. We're just going to add complexity to this demonstration, as you do. You done? Good. Right. So when Mark is doing that, I'm picking up my next slide, which is positioning. Now, positioning is what that grid was all about. Basically, Marcus was telling his device what the world looked around it. Now, that works indoors because basically he has sensors that can reach between 5 and 10 meters. Once you move out of the indoor, out in the real world, large-scale mixed reality, like a construction site, like a development site, like a football pitch, you have tremendous amounts of problems because that device is nearsighted. There are ways to do this, though. You can have three-dimensional reference models of the world. Oh dear. Yeah. Well, that was that timekeeping. You can have three-dimensional models of the world in which you can use to position a device out in the open. The problem is that those models are really, really large. They come from LiDARs, like in self-driving cars, or by you scanning your own street, or Stockholm municipality scanning every street in Stockholm, which generated 28 terabytes of data. The problem with that, you can't store 28 terabytes of data in a device, storage, processing, and so forth, and you can't access it quick enough. It's too much. But you can slice it if you want to. If you put the relevant position 3D data in the edges of a network that are geographically distributed, you can slice the data by location. That means that you're not querying 28 terabytes of data, you're querying, say, 2 megabytes instead. That helps a lot in these cases. And the last thing that I'm going to talk about is rendering. Now, you can see Marcus is doing what we call mixed reality. That is to say that we're blending virtual objects with the real world, meaning that we share attributes between the two. So you can see shadows that the virtual objects are sending out in the real world, in the viewport. You can also see that reflections are being picked up from the real world in the virtual objects. We're talking about Hollywood computer graphic level of quality here. We're not talking about text labels floating around following QR codes or something like that. This has to be like millimeter precision, really high definition. Once again, extremely processing intensive, extremely complicated to do on thin devices, let alone rather expensive thick devices like that one. That's a great example of what you could do in an edge cloud again. Because in the cloud you can do other things, which we think are really, really interesting. If you think about doing things in a centralized, or like centralized as a cloud way of thinking, you can start to do like machine learning, artificial intelligence, on video, on objects. You can do all those kind of things that are going to be so difficult to do on individual pieces of hardware. But you can utilize the full system of many devices using the same for machine learning to understand object recognition, occlusion, algorithms. You know, the list is really, really long. That's another benefit that you can get from doing this in an edge cloud. So, hopefully, if Marcus hasn't dazzled you into believing in this, you understand that this is all about moving what's being done there into an edge cloud environment for mixed reality. That can be used for city planning, but many other cases as well. We can talk about education, we can talk about industry, workplace, you name it. So why a mobile edge cloud? Well, The experts argue about latency here in terms for mixed reality. How quick do you need to do things in order for you not to get dizzy? I'm going to offend some of my colleagues, or maybe it's going to be a fist fight afterwards or something, but we need to do what I just talked about, end-to-end within 10 milliseconds. Like sending something that the device can see, send it up, position it in 6 degrees of freedom with ultra-high precision, render what might be in that viewport back to the device within 10 milliseconds in the real world. Very few technologies can do that with less than 10 milliseconds of latency. That's one of the major reasons why we think this is a great example for how 5G and future connectivity and connectivity systems and networks can be really, really interesting in this domain. For the first time in my 13 years at Ericsson, I've finished 50 seconds before my destination time slot. Thank you so much for listening. We'll be here the whole day.